All right, so the third distribution, or the third discrete distribution I want to show you is the hypergeometric distribution, and it gets again a little bit more complicated. So again, we have the hypergeometric distribution whenever we want to ask a question like drawing from a bowl without replacement. So that is again the concept here. And so the formula is like a ratio of certain combinations where, for example, capitalized K over the lowercase k, that would be, for example, capitalized K factorial over lowercase factorial times the capitalized K minus the lowercase k factorial. So it gets a little bit complicated, but of course, as you see, this can also be written as, for example, from A choose B, right? So maybe that looks more familiar. I don't want to spend too much time on the math, but want to rather emphasize the application. So N is the total population. So that's basically the items that we have in a bowl or in a bucket. Then capitalized K is the total number of successes in the population. And that is, in Excel language, population underscore S. The total population size is number underscore population. Then lowercase n is our sample size. And in Excel, that is number underscore sample. And K is the number of the lowercase k, is the number of observed successes in the sample. And in Excel, those are the sample successes. Okay, it sounds probably a little bit confusing, but I hope it gets clear if we take a look at this example here. So what's the probability of getting X successes in N drawings, or in a sample of N, from the following bowl? So in this bowl, we have a total of 10 balls, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is, in Excel language, the number population. So the number underscore population is 10. It's just, there are like 10 balls in there. Let's say I want to know what's the probability that we get 2 red balls. Well, in Excel language, that would be the sample successes. So I want to know what's the probability that I get sample successes that are equal to 2. But of course, I need to know how big is actually the sample size. And the sample size, let's say, is 4. So I want to know what's the probability that when I draw a sample of 4 balls from that bowl, that I get 2 red ones. So the number sample is N. So this is basically the N, the sample size, and that is 4. Well, and then Excel still wants to know, well, how many successes are in the bowl? And we have 1, 2, 3, 4, 5 red balls in there. That would be the population successes. population underscore successes. Okay, so now we have everything that we know. Well, we could use this formula, but it's a little bit tedious. And maybe I'll do it at the end. Let's first go to Excel right away. So let me pull up Excel. And maybe let's, okay, now we can't see that. Okay, so again, I want to know what's the probability that if we draw from that bowl that you see here with the 10 balls, 5 of which are red, 4, that's our sample size, that we get 2 red balls. And that is exactly 2, not cumulatively, exactly. So now we use the formula, well, hype, let's see what we get. And then you see there's already a suggestion, hypergeometric distribution. And then, you know, Excel asks you how many sample successes. Even if you don't know it, you still can click on it and Excel will pull up normally a help option, which I don't see right now. I don't know why. So maybe it's just not a clickable link, but the sample successes is 2. Okay, sample successes 2. Then the number sample is, how big is our sample? Well, that's 4. How many population successes do I have? So the population successes are 1, 2, 3, 4, 5. 5 red balls. And how many balls are in the bowl in total? That's the number population. That's 10. And do I want it cumulatively or not? The answer is no. So 0. And now I should get the probability, which is 47.6%. Which is 47.6%. So, because there are a total of 5 red balls, so maybe let me we can also take a look at the probability distribution. Well, maybe I can squeeze it in here. Okay. So now we calculated the number of successes for 2. What does the distribution look like? The number of successes is, I can get 0 red balls, 1, 2, 3, 4, 5. So those are the number of successes that are theoretically possible. So let's calculate the probability. And then again also the cumulative probability. Okay, so we use the formula hypergeometric distribution. Okay, sample as successes 0. So my number sample is, actually now I want to change it to 5. So now I want to know the probability that in a sample of 5 I get all 5 balls, or 0 or 1. So note, so now I don't have only a sample of 4, but I would like to see the probability that if I can get a sample of 5, that I actually do get the 5 red balls. So the numbers So the number sample is 5, the sample size is 5, the population successes is 5, and the number population is 10, and I don't want it cumulatively. Okay. So the probability of getting not a single red ball in a sample of 5 is pretty small. And you can see that again the sum of all possible events. So what can happen theoretically is that when I draw a sample of 5 from that bowl, that I get either no red ball, 1 red ball, 2, 3, 4, 5. Those are all possible events that can happen. And you see that those events sum up again to 1. That's why I wanted to switch from a sample size of 4 to 5. So now let's do the cumulative probability. So again, we go for Hypergeometric dist. Sample success 0, sample size, number sample 5, population success is 5, number population 10. But now we want it cumulatively. Okay, for 0 it's again the same. And yeah, this is what it looks like. Okay. So if you want to also take a look at maybe the individual distributions, make it a little bit bigger. So let's just, okay, so it looks a little bit normally distributed. And what about the cumulative one? Insert recommended charts. Again, we can also draw it as a line if you want to. Yeah, it looks similar to the other cumulative distributions that we have seen. But anyhow, so at this point, so now we know how to use the hypergeometric distribution. And the last thing I want to do is, and I hope I will not regret it because it might be a little bit more complicated, use the formula. And so let's take the formula here. Okay, let's see if we can replicate one result with this formula here. Okay, let's say I want to know what's the probability that we get 2. So I want to use this formula so that we have 2 successes. Okay, so now let's start with the numerator. Okay, so the number of k is the number of successes in our bowl, and there were like 5. So now we would say this is equal to combin from 5 number chosen 2. Okay, times combin. So we have a total of 10 minus the successes, so that is 5. 10 minus 5. And in our sample, we also have 5 minus 5. So, and our sample size is 5. And the number of successes, of course, is 2. So that is 10 minus 5, 5. And here we have our sample size is 5. Minus the successes, so 2, that's 3. Divided by combin. And let me get out of the way. 10. And sample size 5. So now, unless I made a mistake, I hope we will see here now 0.39, and that's what we see. Okay, so of course, but nobody would use this formula the way I just did, but that is how it works. Okay, so I hope this clarified how the hypergeometric distribution works. And again, the hypergeometric distribution is concerned with drawing without replacement. Okay, but let's just stop here, and then let's turn to the last distribution, which is the negative binomial.